the organizers of the TUG meeting in Rio, especially to the president of TUG for the opportunity to talk on this occasion about our work. Over Anna and myself, of course, there are many other people involved in the project and specifically in the development of the package. Here you see their names. They worked both on the level of the writing and testing the package, as well as on the fact of extending the functionalities in some way to somehow make the life easier for those who want to use it in a way that I will try to explain you later on. First of all, as an introduction, allow me to make a brief story of how this came out. Actually, everything we did exists within the activities of this laboratory for the research and experimentation of new assistive technology for STEM, entitled to Sergio Polin, who was one of the very early co-workers, cooperators of Anna in her activities as a referee for students with special educational needs at our department, who unfortunately passed away some years ago. So this laboratory was established within the framework of a big project of our department, which was supported among the rest by the whole university, by the coordination of Professor Pavone. She is actually the deputy rector for the disability in our university, and specifically by Anna for our department. What we do, what we are interested in, is to test, develop, and possibly optimize technologies for the access to advanced studies of students with physical or sensorial disabilities. So these are some of the main supporters and partners, actually the University of Turin, our Department of Mathematics, actually two foundations, one connected with a bank and one connected with La Stampa, which is one of the major newspapers in the city, and also this Institute for Research, Training and Rehabilitation under the Italian Union of the Blind and Visually Impaired People. So, as I said, we make research, real research here, experimentation of assistive technologies, and also what we call in Italy third mission, terza missione, which actually is the dissemination on our land, on our territory of the results that we obtain. Actually, what we focus on, what we concentrate on are, in this moment, the digitalization and computerized processing of content which involve science, technology, engineering, and math, specifically math, their application and accessibility. So actually, in our work, in our department, we take special care to people with visual impairment in the framework of an official agreement between our universities and this entity that deals with the blind people. That's the group. So Anna and myself, she is a full professor of analysis at our department, and I'm associate at the same department in analysis. It looks to be formed by really many people. Unfortunately, many of these people are not having a permanent position at the university, and some of them are actually volunteers. I mean, especially among our testers, we would have never been able to obtain what we got without actually them giving us a lot of their time in checking and testing and giving us feedback on the result that we had, both for the package as well as for the other technologies that we were checking. So in particular, Sara Cobal was giving us a lot, Christian Bernareggi as well, who was on the previous page, Elsa Tornavaca and others who were actually really giving us a lot of their help. Actually, we're also a member of this Italian consortium, National Italian Consortium for Computer Science. Another activity that was run recently was this project called DAPARI, which stands for Disability in Companies, Advanced Professionality, Research and Inclusion. That's a project with one of the local insurance companies and another department of the university, actually the Department of Economical and Social Sciences and Mathematics and Statistics from our university. So this aims at supporting, in general, persons with disabilities, again, in particular, visually impaired persons, and helping them to move from the university training to the employee world. So actually, starting from November 2014, Dr. Tonaraka, who actually is working at this insurance company, has been granted a work of 4 days per year at our department as part of her real job. And actually, in cooperation with the, Città Metropolitana of Torino is one of our local government institutions. This was done jointly with them, and actually we organized a course of 14 hours for visually impaired people to reinforce their IT competencies, actually in general to help them to enter the world of work. There were 9 fully paid internships for 3 months, where the participants could really develop the competencies acquired during the courses, and 2 of them actually turned into positions, true work positions in some companies. And actually this really gave an opportunity to this person to widen their work opportunity. So we hope that we will be able to repeat such experience. Okay, now to get closer to the real main subject of the talk. So nowadays, as we all know, people in particular with visual disabilities that want to undertake university courses have new instruments available, such as screen readers, braille displays, screen magnifiers, speech synthesis software, and so on. So all these technologies actually perform very satisfactorily when text is involved. So when one has to read a book, a novel or whatever, or say, Italian literature, whatever, that's very good. But when mathematical formulae enter, then that's a problem, that's a big problem. And the fact is that very often, both formula and graphs are represented as 2-dimensional objects, while the language is, of course, 1-dimensional construction. As we, of course, very well know, a great deal of teaching material within the mathematical courses at university level, but not only university level, not to mention research, papers, books, and so on, consists of PDF files produced through LaTeX. But in general, by itself, when we generate a PDF with LaTeX, the formulae are not accessible by screen readers and braille displays. The trick to make them accessible is to insert a hidden comment inside the PDF, so an actual text, similar to what we do for making web pages accessible. And actually, again, there has been a big effort to achieve, as we know, accessible PDF documents through implementation of some packages. But one point, at least as far as we understood in our experience, is that these tagging, commenting, inserting the actual text that makes this object accessible to readers must be performed manually. So for instance, the author writes the formula, and then he has to add a description for each formula which is written. So of course that's already a bit cumbersome for the new documents, but clearly if one has something already written, that's even easier. And for instance, these packages, if you look at that in our earlier stages of this work, also does not allow some special characters in the comments. And also, with some of the solutions that were implemented along the years, there are problems in the reading because, say, a reader like NVDA or JAWS, that are among the most widespread readers in this setting, actually, maybe the reader reads the formula incorrectly and then the correct comment. So that's not what we want, of course. So what were our focus? What is our aim here? So first of all, of course, we wanted to focus about the accessibility, so making mathematical formulae in PDF generated by LaTeX correctly readable by readers and braille displays. So this was the first thing. And then the other counterpart of this aim was to avoid, as far as possible, that the author needs too many extra effort or to insert too much additional LaTeX comment to achieve this goal. So those were our two aims in this, at least first development of the package. So, in view of this, we started from the package AXUP, and there actually there were already available some tools for commenting formula. And in particular, here special characters in the comment are allowed. But again, by itself, this package does not provide the comment automatically. So again, the comment should be manually inserted. So what did we do? Okay, with our accessibility, actually the package automatically produces an actual text corresponding to the formula. So again, let me repeat, we were just focusing on the formula access. So that was our aim. And okay, this actual text is really inside the PDF document, but the screen reader reads it without reading any incorrect part of the formula before or after. And clearly this is obtained by tagging it with making it which we call marks both the actual text as well as the formula itself. Okay, so how is this obtained? So of course I will not go through the whole code that's available, so you can look at this, but just for simplicity. So the thing that we did was to redefine this command, which is in the XSUB package, which is actually the one that allows us to insert the command to the formula. And this thing here, the /s/span, and then the next two lines, are those that actually really insert the command to the formula in the correct way between these two minor and larger. Then, here, you see the wrapper. So this one takes essentially the LaTeX code of the formula and make it as hidden actual text. So that's what we do. So the thing is that we take the whole body of the equation and put the command here. And finally, the command equation star, and so on. In the moment we can handle the inline formula and numbered or unnumbered formula like equation and equation star, or also the construct with the backslash square parenthesis and close the square parenthesis. So this is just done by essentially calling the wrapper here after having collected the body of the environment. So that's how it works. Let me try to illustrate this maybe with an example. So that's let's say something that you could give to maybe very early part of an algebra course or geometry course. So the golden mean. So that's how the typeset PDF looks like, and this is the LaTeX code. So here, as you see, the only thing that we do to make the formula commented by taking the code and having it put as actual text in the typeset PDF is uncommenting this use package. Here there is really nothing else. Okay, if you typeset this one as it is written in this moment, so with the use package commented, okay, of course that I suppose totally unreadable, of course. It's a honest binary file, so there is really nothing we can recognize here. If we typeset it with the accessibility package, so meaning the AXUP and all the other packages, okay, it's still not very readable probably, but I hope that you can really see here the command to the formula, this one here, and that there is the real formula written elsewhere. Okay, so what I try to do now, I hope this will be heard at least in a reasonable way, is to try to let you hear or let you see from if the audio is not good enough, what happens when you make the tests of reading these files with VoiceOver. I mean, I'm using a Mac here, so I will try now this with VoiceOver. So this one is the typeset LaTeX file with no accessibility. So let's see.
VoiceOver at TiVo Acrobat in Macintosh. users in testo. The golden mean. T-troll.
Sorry, let me try it again.
F5 pulls empty. VoiceOver non-TiVo.
Try it again, sorry.
VoiceOver at TiVo Acrobat Reader in Macintosh. users GNDALF. The golden mean is the number 1q5 square root.
Okay.
The
I suppose you have
number 1q5 square root.
Okay, so
VoiceOver
I suppose you have already heard the fact that here the formula is read incorrectly already at the first stage. So the next one is actually typeset with the accessibility package on. So let's see the difference.
VoiceOver at TiVo Acrobat in Macintosh in testo. Golden mean. The golden mean is the number. Retroversa / rock grapha sinistra 1 retroversa / sqrt grapha sinistra 5 grapha distra grapha sinistra 2 5 number golden mean is the number retroversa rock grapha sinistra 1 retroversa sqrt graph 5 grapha distra VoiceOver non-TiVo.
Okay, so I don't really know how well you could hear or how well you could see the thing, but the point is when the package is active, actually the reader can recognize the LaTeX code. The thing is that here I put the English voice, but the system is in Italian, so there were some non-completely well-read parts. But essentially, in the second part, the LaTeX code is read and not the formula before. So what else we did? Okay, there are some scripts that complete the package functionalities. So, of course, in principle, the idea was to try to apply our package also to existing LaTeX documents. Okay, in this case, there are some pre-processes to be done. In particular, the equations with dollar or double dollar should be transformed into / open parenthesis, / close parenthesis, and the same for the square parenthesis. So we have a pre-processing script that handles some of these cases, which can be downloaded and used. Also, of course, if one has a custom macro in a formula, this is copied as it is in the text, so this can be kind of not very understandable. So maybe one can be willing of expanding these macros. And this also we have a script that that's not the only thing. I cannot having this test done with you today because I don't have the programs on my system. But one point, of course, is the following: our testers they know LaTeX. They know LaTeX quite well, and they were already very happy with having the reader of the Braille display to read the LaTeX code. So for them, this was already really understanding the formula. But clearly, the next step, actually what we wanted to achieve, was to have that read in a as natural as possible language. So we were actually also developing some dictionaries for both for JAWS and VBA stream readers that actually read the LaTeX command into natural language. So in the moment they exist in Italian for sure and in English as far as I remember. Of course, the Braille display will still show the formula in the original LaTeX representation, but for instance, our testers, as I said, were very happy with that. Okay, what else? What comes next now? Well, of course, in particular when one has existing document, one wants to start from some editable format, so OCR are useful in that. And okay, they need an image segmentation algorithm and then a character recognition algorithm. So what we are doing, jointly with some colleagues from our computer science department, is to develop a European OCR that recognizes automatically both text and formula. Of course, the recognition of a formula needs a much larger quantity of patterns and existing patterns to be recognized. So, of course, these algorithms are quite heavy to develop. Actually, the cutting position, the reason is that cutting position can occur in any position, essentially vertically, horizontally, or diagonally. So it's hard to really separate the various. And at our best knowledge, the only OCR that presently does a job like this is developed by a network of Japanese university under the so-called Infinity project. But as far as we understood, they implement different techniques by what we are aiming at. We also dealt with the other kind of disabilities. So in particular, there's been a production of a database of videotapes of the classes to the bachelor degree in mathematics, again, to help these people to possibly listen and re-listen the lectures. And also with persons with some disabilities in the upper limbs, actually, again, we are just trying to study access through voice commands and automatic transcriptions of both and not with math talk. Other experiments that we are doing, accessibility of Moodle 2, accessibility of university admission tests. Of course, we are in contact with other universities' disability offices to try to make this a network, a system effort, not just a single university one. The idea, of course, the main goal would be to be able to include this in a full, accessible PDF LaTeX under the regulation, the standards that these are requested nowadays by the law. Of course, that's a long-term goal, but we would be very happy. Our small contribution here could be useful to make also mathematical text accessible under this point of view. Graphs, that of course is another completely different story, but that would be also nice. And finally, there are, in this moment, courses in transcription of text containing formula, again with this association taking care of blind people. Organization of courses for teachers, we did already, essentially since we believe strongly that LaTeX can be a tool already at other levels of teaching, not just university. What we did was to call to teachers of high school and also to intermediate schools to learn LaTeX. And that was, again, at least interesting to see the enthusiasm that some of them showed up when we proposed the course. The handling of the multi-line environment in this moment, it's not covered by the package that is in this moment being done, but that's basically completed. I mean, it's just a matter of writing down the code. Should really not take very long now. We also want to create an accessible library. In the moment, we have a colleague who granted us the LaTeX code of these two books in Analysis 1 and 2, and a colleague from Geometry as well. And of course, we are looking permanently for colleagues who want to contribute to this. There is also the possibility, and we are exploring that. I mean, Anna and myself, we are from two, say, nearby but different families of people working in analysis. So she's from the variational world, and I'm from the Fourier analysis world. But actually, we have in mind also to make some real math research in this field. Again, natural language generation even more developed than what we have now with our dictionaries, which again, by our testers, is already very nice leap ahead in the reading of formula. Human-computer interaction, then also the developing of virtual physics laboratory and a fully accessible chemistry laboratory as well. And also accessibility of statistical software for data analysis, that since this we are heavily using in our courses at the University of Turin, so we also want to make an effort in making this as accessible as possible. Let me also add that when we presented this package at the ICC-HP 18 last week in Lean, we also were suggested to make some connection with MathML by Neil Seufer, who was there. Actually, was suggesting that. Okay, here you can see just a few of the papers that were wrote by people in the group along the years. The last one actually is what I mentioned, and these are the proceedings of this conference that was just being held last week in Linz, where we actually presented the package for the first time. As you know, this is now already available on FAN, and our repository is this one, and I thank you really very much for your attention and again for the opportunity.
Any questions? Sandro?
Yes, I did.
You here? Can you hear me?
Maybe I now take you back.
Yes. Well, thank you very much. It was a nice lecture, and we have one question for you.
Yes, please.
One small question. I tried your package, and I think I found an error and put an issue to a Git repository. I'm quite unsure if it was a right one, because the address is not in the document. Perhaps you could edit.
Did you understand it?
No, sorry. If you could repeat it, because I simply didn't hear the question. Sorry for that.
Say that again. The address is not...
The address of the GitHub repository is not in the documentation. I'm not sure. I tried to add an issue, but I couldn't find it.
The address...
Oh, really? Oh, well, okay. Good to know. I will then tell to the guys who handle it. Sorry. Okay. Thank you very much. I will make this check immediately. I mean, the others are listening, so they should know. I mean, I hope that now the two youngest are just checking the address they gave me. Okay. Thank you very much for that. Thank you very much.
And you have another one here.
Okay. My question is, why did you choose to hook into actual text rather than alt, the alternative text, given that alternative text is what appears in the PDF standards for accessibility, for PDF UA?
Okay, that's a good question. Actually, that's because, at least from the test we did, that was read by the readers, but not the others, for some reason that I simply didn't. So the way we market it was that it's not a choice just by the users. For some reason, the other one was not really working, or at least that's what we experimented at the time. Right. But as I said, we are in principle aiming at making this tagged in the correct way. So that was just the first experiment, and it worked. I mean, we are aiming at. Maybe I said it too quickly before, but the real final goal would be to really obtain fully compliant PDF under the rules. So of course this will be updated in the future. Let me add that there were also some small strange things for instance, the underscore, for some reason that we really could not understand, was not read correctly. So that was really a mystery. So we had to change it with the some backslashes. So that these are the mysteries that sometimes one encounters. I really cannot say. But for that thing was just an intermediate choice to have something which worked with the readers we had at the time. But of course, the final goal is to have it really fully compliant with the rules. So,
okay, if I may, it's not a question but rather a comment about the second part of your talk when you were talking about mathematical OCR. There is a huge community besides blind and blind community which would be very much interested in this. There is a community of people who are trying to tag semantics of existing mathematics. Right now they have a very small very small pool of what's in Wikipedia and so on, but if you can get OCR of historical documents, it probably would be very interesting for them. We at TUG board, we are going to publish a paper from people in this community, and I would suggest you to contact them. They would be probably happy with this.
Absolutely. No, if you can send me contact data for them, for sure
I
we
will.
will do. I mean, as I said, we are really eager to make the widest constant as possible for these, I mean, the developing, I mean, as you see, we have a full running project, really trying to take care, I mean, of course, once again, our focus was on the visual impairment, because that is how everything started, but we are not really limited to that. And actually, this challenge is one of our most, I mean, again, something that we are really eager to develop as much as possible, because, I mean, on one hand, there is really some real math research that one could do there. At least we have this feeling. And then, of course, it's also, I mean, interesting from the point of view of just creating a library of existing documents that can become accessible. So, of course, that's really one other goal. Yes, thank you.
Sandro, thanks very much. Thanks again.
You're welcome. I have to apologize that I will not be able to attend the round table because tomorrow I leave for a mission in Germany. So this will be with Anna and the other colleagues. But once again, thank you very much to all of you, all the TUG people, because, I mean, setting up a talk in a matter of less than 1 week was great, really. So we appreciated it very much, and we are really eager to cooperate in any possible way that you could find useful, and same side from us. I mean, from that point of view, really, thank you very much once again.
Thank you.
Bye-bye. See you. Bye.
Bye.